at Curiosity, the Why Didn't You Test That podcast experiences an insight on the many sides of better software delivery.
Hi, today we have with us Adam Sandman, who is the 18 years with starting Inflectra and growing it. Do you want to just give a little bit of a kind of breakdown of what you've been doing and the growth in Inflectra and what it really does?
Thanks for having me on the podcast. And we've worked actually, I think, with yourself and some of the previous companies in those 8 years over the years.
Yeah.
I think you can mention the names if you like. I don't.
Grid Tools.
Grid
Then we got taken by
Tools.
CA.
Yeah, that's right.
Yeah.
So we've talked with you and your team on and off those 18 years. So it feels longer than 8 years. So I started the company in 2006 to provide basically affordable quality assurance, test management, quality management software. I mean, it's funny, the most popular test management and testing tool was Excel in 2006, and sadly it might still be the case in 2024, maybe not. And quality issues still seem to be the problem. So when
I'll just interrupt you there. It was Excel, but then you went off and had all of the HPALM suite, which seemed to, or whatever it was called, and that just seemed to eat all of the budgets for testing forever. In other words, no one had any budget because it had been sucked up by HP. So it was either that or it was Excel.
And actually, the story is interesting, what you just mentioned, because I started the company in 2006 because I used to work before that at a consulting company called Sapient. And Sapient had decided to use on one of our projects HPALM, although it was Test Director back then, Test Director 7.6. And I was the lucky project manager who got to use it. And I went, wow, this is a really good piece of software. And then I said, hey, I would love to use this on my other projects. And I looked at the budget and went, I guess we're going back to Excel then. And that was the founding story. So it's funny you mentioned that. Thanks for the lead up. So I started the company to try and give companies an alternative to option A or option B. Let's see if it's option C. And other companies did that as well. I won't pretend we're unique, but I think there was a whole generation of companies that launched around that 2006, 2008 timeframe to provide more affordable solutions for testing teams who really didn't have a lot of options other than the Cadillac or the buggy. And so the company started off with that mission. And then over time, we realized with the Agile Manifesto that we had to appeal to integrated Agile teams. So we added functionality around planning, integrating with Jira, Azure DevOps, although it was TFS in those days, adding functionality for cross-team support. And then we realized that test automation has promised much and not always delivered. And so we got into the test automation space with a codeless automation tool and various other add-ons to build out our platform. And the cloud came along. We've released cloud versions of our products because originally it was all on premise. And then now we get to the point where data privacy, security, compliance becomes really important because people realize that data is so important. And so we've really spent a lot of emphasis in the last couple of years on data privacy, compliance, risk management, adding functionality to our platform to help companies accelerate their compliance processes so it can be at the same cadence and speed as their delivery. What we find is that companies can deliver software every 2 weeks through CI/CD. They can deliver paperwork every 2 years, and that's a major cadence mismatch. So we want to help shorten the cycle and bring all of the disciplines at that same speed of delivery, not just development, because that's the problem. DevOps brought IT and operations at the speed of development, but no one thought about everything else that the project managers deal with, that the compliance managers, the BAs, the risk manager, product owner. The product owner has so much more on their plate nowadays with security, privacy, than just development and IT. And how does that all happen at the same speed? So that's sort of the company's ethos and sort of founding story all rolled into one.
Okay. Actually, the compliance, that's quite an interesting thing. So let's talk a little bit about the kind of what you mean by the compliance there in terms of what people are actually having to produce. I mean, is it just a documentation associated with the change, or is it actually saying that this feature is going to be looking at a certain private piece of information? What's the actual? How does that fit into a project manager or program manager's kind of role, I suppose?
It depends a little bit on the industry and obviously what they're building. But we have clients, for example, that are building systems like medical devices, or maybe it's going to be an embedded piece of software that's going to be in a heart monitor, or it could be a self-driving car, or even just going into an existing car platform, but it's going to be something that's downloaded into the car over the air updates. They have to be able to prove that they're doing no harm. They have to be able to prove that the requirement, that line of code they introduced, ties back to a requirement. There's traceability and there's auditability. Who touched that code? Who touched that requirement? there's all of the almost like the custodian, you have like a cold chain when you're dealing with food and fish and things. Well, it's almost like we have the software supply chain. It's the same thing. We have an idea and a requirement that's been approved. How did that manifest itself into the code base? What else was included into the code base to release that piece of software? Maybe this third-party library is open source, and who tested it, who validated it, and if it doesn't work, or there's an issue that we didn't expect, do we do risk analysis on that? What was the likelihood of harm? And I think this is a methodology that we've seen in life sciences for many, many years. FDA mandates this, but we're starting to see it now be applied in other industries where software has gone from being something that you just install and it does business applications that are relatively isolated to being such a critical part of a business. I think the other thing we're seeing is because of cyber, people want to know what's the bill of materials for your software, and that goes back to how was it developed, how was it tested, and so things that I think were more niche 5 years ago have become much more mainstream. When we sell our product, we're basically being asked to do the same thing for our own code. So, and we're seeing our customers in banking, energy, finance. Another example would be energy. We have a customer of ours. Every time they deploy a new piece of software, and they're not even developing software, they're literally an energy company that runs power plants. Every time they deploy a new piece of software, whether that's an ERP package, it's Outlook, it's a new version of Salesforce, or it could be something very specific to energy, something that's running in a control room, they have to be independently tested and verified. Not just that it works, but also does it meet the requirements, does it meet the needs, all the way back through that chain. And they're not able to rely on a vendor doing that. It has to be done independently. Same thing with hospitals, same thing in governments. And so what we're seeing is this trust and verify is really now becoming trust and will verify. And that's why I say compliance. It's not just about generating paperwork, which is a part of it, but it's also having the data to back that up. Where's the data to prove that you've done what you said you did? When was it done? Who did it? And is testing covering all the necessary risks? And especially with AI adding uncertainty into the mix, risks and risk management has gone from being, I think, again, a niche discipline to being front and center. Risk-based testing, risk-based development. How are you managing that?
Yeah, I mean, it sounds great, but the reality is that we see it's so rare to even have anyone even have this kind of level of conversation that we're having. I mean, we're having a big discussion about inner and outer loop at the moment.
Right.
And it's this sort of idea that people they've automated certain bits in the middle, and then they just don't care about anything else. They genuinely don't care. It literally just chuck it over the fence, and then all they have to do is say, well, this bit's really automated and it's tight, and we do this and we know that, and we might, if we're really advanced, we might do some code scanning on it or something like that. But in terms of tying anything back, I would say it's almost it's complete rarity from what I'm seeing out there. No one's really doing anything like that. So basically, I would suggest everyone buys your software immediately.
I agree.
So yeah, and ours, of course.
Yes, absolutely.
That's for a different reason. I mean, we've talked about complexity a lot, and over the sort of 20 odd years of the various companies, understanding the complexity for change is been sort of highly debatable. They say, oh, it's just one flag, but actually, I mean, I think the best way to think about complexity is how difficult is it to test, and that is really, a simple change. It's a whack-a-mole. You make that one change and you break all sorts of things. Oh, we're just going to change this to a null on one JSON field, as opposed to a leaf, an empty leaf. Suddenly, all hell breaks loose, and
yes.
The risk of that is absolutely extraordinary. So that's kind of where we specialize in. We're much more focused on coverage and being able to calculate the minimum number of test cases, et cetera, et cetera. But in terms of the practicality, once we increase the coverage, what we'll normally do is just find a load of bugs,
right?
And then they'll go, oh, and then they'll fix the bugs. But they don't really tie them back to, well, why were we doing that? What was that all about then? Who cares? What was it for? And also the other one of that is, before anyone makes a change, they don't understand the complexity or the risk. They'll just go and make it without sort of an understanding of, where does this fit in a sprint cycle? Because it could potentially derail your sprints for like the next 3 sprints, or you should be thinking of a long sprint or something like that, because it's just too risky. So that's kind of the space that we tend to operate in. But it's kind of it's interesting. The other one is kind of hardware testing, and the initial stuff that we did on coverage modeling, along with Richard Bender and cause and effects modeling, was actually very much worked on physical devices, which in their cases was torpedoes, which tended to blow up at the wrong time.
At the wrong time, right? Blowing up is okay if it's at the right time, in the right distance, and the right range, right?
Exactly. So that's when actually the discipline that's the first time I came across it. But then trying to get those kind of disciplines of back into the world of software just seems to be, it's still seat of the pants. It's still subjective. The hope that AI is going to come in and fix all this stuff, is a complete misunderstanding, because all the data that has been gathered is so subjective. And the complexity, code, you can reverse engineer code, fine, but actually trying to reverse engineer a requirement, and also data as it evolves across an entire, over the sort of lineage of, even if you look at someone like Nationwide, which Rich worked with, they would take over another insurance company or whatever. The data that was brought in, they didn't go back over that data and try and make it the same, fit all the same codes. So they end up with all this data which doesn't match. But then trying to go back over time and trying to infer patterns on that, and what does this mean? Means that the data is continually changing. So all of those types of subtle things just never seem to be really grasped in the software industry. I mean, there's a lot of lip service and this magic hope that AI is going to be able to go off and pay all that technical debt. It seems like having something like Inflectra, for example, would at least give you, probably closer to sort of an 80% faith that the metrics that you're gathering actually have some value that can then be applied to speed up processes.
And that's true. I think also when you mentioned also, let's say you find these risks and then you fixed, say, 20, 30 bugs. There's also a step which should be done then, which would be, what is the impact of fixing those bugs? So even by fixing one of those 20 or whatever number of bugs you found, is adding new risk, because that bug itself has no doubt tentacles into other parts of the system.
Sorry, again, coming back to cause and effect modeling, the thing there, you would design, say, 185 tests,
right,
and then what would happen is 184 of them would work, and they say, well, that's close enough.
Right.
Absolutely wrong, because when they would fix that one, they would uncover another, because usually what it is a flag or some if statement somewhere is actually being masked. And once that mask goes on, suddenly this whole chain of other code goes down. So the ability to actually check the in toto with a clearly defined set of test cases which are testing the veracity of each of the decision gates is really the only way that's going to work. Otherwise, as you suggest, you pull that one thing out, bash, the whole lot falls down. And we've all got so many stories about, we're just going to fix that one thing. Nah, we'll let it go, and you fix it, and suddenly you're going to do a release tomorrow, and you've broken everything else,
Right. So one of the things that we actually do in our internal bug review is we rate everything with a priority, which is the business priority. How important is this in our own product to improve? But we also track everything with a severity, and we actually use a detectability, almost like a detectability model, which is that what is the scale of the change? And we start with a small scale. Is it hyper local? Is it deep? Is it wide? And before we make any assessment of whether we'll do something, we do an analysis of what does it touch, and we actually look at the code. Where is that one class being used? And that will inform the priority. And if we see something that might be super critical priority, but if we know it's going to be higher than a very, very localized and verifying that in code that it truly is, then we will push it to the next sprint. We won't do it in the next release, even though it might be tantalizing to do that. And it goes back to, I think, FMEA has the idea of detectability. And in software, we don't think about detectability. We think really about priority, maybe impact and probability, which is the classic two dimensions of risk. But detectability, which you mentioned, is key. If you can't detect something, it makes it much more dangerous to change it. If you've got, like, for example, we have automated coverage of all of the unit test layer, the API layer. If we change something there, we've generally got high confidence that we're going to catch side effects. If you touch the UI, we have some automated testing, not as much as we'd like. So our detectability is low. So therefore, we're much more scared. For example,
I'm loving this, and that, because another thing which I was going to go about was this idea of observability. You call it detectability,
right? Same thing.
Yeah. So the observability during a process is critical to say it worked. you have to have the audit trail of why did it work, because there, it may well be that you're approving a credit rating. Yes, we approve the credit rating, but you absolutely need to know that all of the decisions that were made to confirm that were the ones that you expected, because what will happen is that there will be something in there which is switching the switches on or setting something incorrectly. So the observability and also, I mean, this is where some of the things about when what's the job of a tester? I mean, the job of a tester should be right at the beginning to tell people how do we build a system that is testable.
Mm-hmm.
How can we prove this? So how can we observe it? How can we turn these black boxes into something where we can see inside it? And to be honest, a lot of it is just let's just put in auditing or codes or transitory codes or intermediary codes as we're passing through. And then when you're looking for your actual versus expected results, which is also another interesting subject, what you should be able to do with looking for the actual results and expected, you should be able to match them to the journey of the data as it's traveling through the system. So that observability is absolutely critical. And did the test work? Yes, no. I mean, the result is probably, possibly, or definitely. And if you want to move towards definitely, it worked for the right reasons, then you do need a very strong set of observability points built into the code, I think.
And I imagine with decision tree type applications where you've got lots of different, like claims management and insurance with lots of rules, you could get the right answer for the wrong reason because two bugs cancel out in one case, and now you think you've passed the system.
Totally.
What do you think about AI? With AI, what does expected result even mean? I mean, if you've got a model that's learning from a set of data that may have been, as you mentioned, from multiple different data sources that have been aggregated over time, how do you know what the right answer even is? A training data set has been learned independently of a human, and it seems it's able to correlate the data and give you maybe reduction of claims. We can reduce claims by 20% using this model, but no one's entirely sure how it works. So when you start to give it data sets that are outside of the range of its training model, it will fail. But how do you know when those boundaries are? Because you've no idea exactly what those boundaries truly are anyway.
Yeah, so
expected results. Yeah.
Well, what you're doing there is you're actually using the data. The data is is what you're testing. So
Right.
the data, building those data sets. We've just noticed there's been an uptick now. People have kind of piled into this market and saying, we because you can't actually test the code, which is the AI. The only way to do it is to actually build these training data sets and in effect kind of say, with this training set, we would expect this result. Now we've been kind of doing that for ages and ages, mostly to do with business intelligence systems, actually, because business intelligence systems say, well, did your report work, which is the old-fashioned way of thinking about it. Did it detect this? And the answer is, well, yeah, I got the result. But then what did you do then? Well, I looked at the report and I checked the things, but I said, well, what did it miss? We can't know because it's a known unknown.
Right.
So without synthetic data, which is because we know exactly what is in there and what is not in there. That's been around for donkey's years in our world. I mean, we did it for a big phone provider. About 8 years ago, where they were doing a whole bunch of data warehousing, and of course they were just taking big. They took 5% of their production data and hoped that was enough. But I was just like, well, how do you know this has worked? And they could not even articulate. First of all, they didn't understand the question I was asking. Well, it obviously worked because it gave the result. But I was like, well, prove to me. To me. So it took a while for them to actually get that. But then once they got that, then they were like, oh, okay. So I said, why don't we just, generate, 50,000 of these with all of the patterns that you want within them, and then we can tweak them and look for the different variables within it. So that's another interesting space. Rich, you haven't said a word yet.
It's interesting, like kind of listening to the conversation you guys have been having, and I'll pick up a point that Adam made in terms of the alignment and in the small, if you like, you've got the development and the operations kind of aligned, and they can make changes every 2 weeks, right? And then I think you mentioned that the documentation is 2 years behind, kind of thing, right? And so to me, there is this kind of halting, slowing down in terms of, okay, so if you can make these changes every 2 weeks, and I'll come on to Hugh's point in a minute around the data, if there is this kind of making change every 2 weeks, how do you know what changes you're supposed to be making? And, almost, organizations in their rush to agile have chucked away a lot of the documentation in inverted commas, but part of that is kind of this rutting, if you like, against controls as well, right? And so, I think control functions within organizations have got problems or challenges, again, around establishing or re-establishing themselves within these development teams to make sure that the specific requirements are passed and are incorporated in the first place into those teams. And then how do you actually demonstrate those things, not just in the product in the small, but through architecture right the way through the piece? Because I think, observability comes a lot through the way you design an architectural system up front.
Mm-hmm.
And then almost the implementation of those things is easy after that, right? I think you mentioned the kind of the perfect implementation of a test, isolating the unit to the API to the, minimizing the GUI part. It's hard if those things haven't flowed through the architecture and design. And so in the same way, to Hugh's point around, we can knock out all these things out in a test respect in terms of actual results, but how was this thing actually supposed to work? What was the profile of data that you were supposed to get? And if you don't know that when we've done the test, how are we going to reverse engineer that stuff to get an answer? Because we don't really want to go back to requirements. We don't really want to go back right the way back to the piece. How are we going to use an innovative way to get to the point of an oracle that we do trust? And that's a problem with AI as well.
Right. I mean, it's interesting what you mentioned, because you can release the software really quickly, and it may work from a technical standpoint, but is it truly fit for purpose? What was the purpose? And if the business doesn't put prioritise, say, observability as a facet, as a non-functional requirement, then it won't get built. Like as you know, if it isn't paid for, if it isn't valued by the business, it's lip service. And so when you talk about quality, you talk about we want to build a high quality solution. If the business just says it has to meet the stated tests, and we don't care if it's any good, what does good even mean? But does a user love it? Does it have user adoration? Is it easy to use? Is it fast? Is it safe? Is it able to work in the parameters of the environment it's meant to work in, which may be different than what it was tested for? Those are all these subtle aspects that we talk about quality, and that's why I think the idea of moving from testing to quality is really important. But quality is given such short shrift as well. I mean, one of the interesting analogies I always remember was when I worked in British Steel back in the day, before I was in software in South Wales, and they were doing ISO 9001. And one of the things they had really made the shift towards, was very interesting, was from quality control to true quality assurance. Was they didn't just make a bunch of steel and then gave the customer, here's your steel, you said it's supposed to do these things, but it doesn't, or it does. They would actually start with the end experience was, it's going to be used in this context, which could be a tin can or it could be a car, and they're very, very different types of steel you needed. And they worked back the entire process, and they could tell you from the moment you mixed the steel, before it was even poured or rolled, that this was going to be off. And they could either adjust it chemically and fix it in process well before it got into those later stages, or they could say it's unfixable, we're going to move it through a different process and use it for something else. But software, when we talk about QA, are we measuring quality at requirements, which is essentially the same thing? Are we measuring quality when we're doing code reviews, when the developers are looking at the branch to merge in? Are we doing risk analysis right then? Because if you were to take a true ISO 9000 approach to agile, you would do that at those stages well before code goes into a pipeline. Or maybe it's in a branch. It isn't yet in develop. It's in feature branch. And the unit tests have run. Has someone assessing it qualitatively as well as quantitatively? The answer is no, but they should be.
Very interesting. The other one that's just come to my steel story, because I'm actually looking out the window that way, is the Brooklyn Bridge, which was 20% over-engineered to allow for corruption. So what they did. Well, yeah. Think about it. This was built.
No, it makes perfect sense.
It's because they realized that people would turn up with their lovely, spiral cables, and then of course, as soon as they started making the steel, they're like, put a bit more sand in it, a bit more this, a bit more that. So what they did is, when they did it with the concrete as well, they actually I think it's the most over-engineered bridge in the world. It ain't going to fall down. So because they actually built in for corruption within the bridge itself, because they assumed that people would be bilking them once they got going, and quality control would fall down, so they just doubled everything pretty much. Anyway, we digress.
On that point, though, Adam, I'm keen to get your views in terms of, you've got maybe part of the medical and life-threatening kind of arenas, but the more kind of regulatory financial services and things like that, right? Almost they are regulated, but yet you still get the behaviors of adopting agile ways of working, the anti-patterns of adopting those things. Do you see a coming together of, almost a realization that actually the way we've been operating, maybe in agile, but I think it kind of predates agile as well in terms of when you talk to kind of legacy development of those capabilities. Actually, the way we've been developing these things has got us into a place where it's very expensive, it's very complex, we don't really understand it. Actually, a lot of these controls that are there to try and untangle these things and to make them easier. Do you see that there is a coming together of actually organizations adopting those things, or do you think actually there are?
I mean, you'd like to think you like to think so. So we work quite a lot with insurance companies and with some trading organizations. They seem to be, I think, understanding and appreciating this more than they've ever done before. And I can't say commercial banks maybe are the same. Commercial banks seem to be maybe a little bit behind. But when you look at the anything on capital markets where you got high volume of trading, for them there's a risk of first of all, the financial imperative is if a system goes down for 2 seconds or a second with these high volumes of trading, the financial impact is it's almost like a regulatory fine. And you may get a regulatory fine from NASDAQ if your system is not able to process trades within a certain number of seconds or microseconds now. So I do think some of those organizations where there is a cost of failure is so high, it's almost like it's life-threatening. It isn't life-threatening, but it's almost. I think they are definitely taking this seriously. The second factor I would say is cybercrime. Because cybersecurity tends to force people to look at the unlookable or the unwelcome parts of their organization, I think cyber is also making people reassess their vulnerability. I think SolarWinds for me was the big wake-up call, because until then, people just thought they could throw money at cybersecurity, which was literally better firewalls, training, endpoint security, virtualization. You could do virtual desktops. You could basically assume the software might be crap, but you put the crap in a fortress and it's good. And then SolarWinds said you can do all those things, and not picking on them, SolarWinds, sorry, but anyone who's not managing their supply chain of their software, the internal quality becomes a cyber vector. So I think that from that point onwards, we've had banks and customer and telecom companies. Again, when they look at our software just to use in their environment, we have to give them a bill of materials. They want to know every library we use. They want to see our change history. They're starting to look at some of the practices that we previously saw, mainly in aerospace, some of the more high assurance industries. We're starting to see some of this trickle down. Now, not to every company, but certainly the good ones, and the ones that care about data privacy, the ones in the EU where the EU has more, I think, jurisdictional oversight maybe as well. The risks of data being breached because of a code issue rather than an infrastructure environment issue, I think is also focusing minds. So I would say a lot of banks don't care so much, but certainly the ones that have to deal with the cost of an outage are more concerned. And then insurance, I think, because insurance is highly regulated in terms of you misquote a policy or there's been discrimination. There's such a hyper oversight around insurance right now that I think they're also being more careful. Not because someone will die, but because if they get into a lawsuit, that can be reputationally very dangerous for them. I don't know if you're seeing that too.
Yeah, I mean, I guess if you think about it, that is probably true. I mean, I'm just trying to think of the sort of fairly shambolic ones that we've come across.
I mean, there was that data migration of, was it the bank, was it TSB, and decoupling from Lloyd's? There was a massive data migration.
Yeah, I mean, data migration migration. We talked about it a fair amount. I mean, if you think about most companies, they're generally moving. They're moving from one place to the other because they got taken for lunch with the Salesforce guy, and suddenly that's it. Everything's moving to Salesforce. It can do everything, and then magically they find it can't do everything, and it's too hard. And even the whole data piece of moving over their existing stuff is really, really hard, and all that kind of stuff that goes on. So I'm wondering, in terms of some of the stuff that you do, in terms of that bill of material, whether that would, because we were actually talking about this last, because we were talking about it's the Dutch Customs Office and the Dutch Tax Office who've got a big problem with basically people leaving or technical debt or whatever you want to call it, and we were sort of, I guess, coaching Marcel there about in effect trying to use software to help you build that bill of materials. Using model out the stuff. I mean, even using AI to reverse engineer your your user manuals. You can use it for code to do that as well. But the trouble with that code is there's quite a lot of it which isn't actually used anymore. There's just so much code sitting there. You could spend hours and days and weeks going down this one if statement, and then they'll go, oh, that's never used anymore. So, for example, you'd actually need to run the software. You need to put a code coverage tracking in to say, well, we don't care about this code. Therefore, but all of that is a technical project in my mind, something that you need to go to actually build up that bill of materials where you understand the flows of your top 95% of your revenue and risk-bearing activities, and then from that you then understand what data is actually being created, not the data you think is being created, because that's very, very common. People say, oh, it's doing this, it's doing that, but suddenly you find it's actually not. It's going to the GL, and the GL posts a Kafka message, which then goes to the mainframe, which then does the reconciliation, which then sends the message back down. All of that stuff, they change something and it all breaks because they'd forgotten about that bit. So,
is there a transactional integrity between all those different stages? So if one breaks mid-cycle, it doesn't rolls back and then undoes everything.
Yeah, exactly. And that probably works, but it's just because it was written by the person who wrote it in assembler 27 years ago. So that works, and it's used once a month, but it's worked, and no one's dared go anywhere near it. So there's all that sort of stuff. So I'm curious about how we could use this concept to kind of help people with a sort of bill of materials to help them. Before you move, understand what you got, where you're going, and what the journey is. So, that would seem fairly obvious. Most people do it when they go somewhere. Most people know where they're coming from, and they generally have worked out how to get there. But in IT, not a lot of those.
There's a lot of these zombie systems.
We don't know where we are. We don't know exactly where we're going to, and we certainly have got absolutely no clue about how to get there.
Well, you're right. There's a lot of these zombie systems. I remember talking to some of the airlines in the US. They use they have mainframe booking systems from the Sabre days that literally are mainframes that they daren't touch them because if they change them, no one remembers how they work. Or the Boeing 737 has more lines of Fortran than any other programming language. And again, the cost to certify everything means you're not going to change it. So, but then no one understands this stuff. It was written a long time ago, and documentation was missing. So an example I heard from a friend of mine who works in the consulting space here was that they were moving an IRS tax system, and it was a big old mainframe, and they wanted to recode it in Java. So what they did using AI is they used the AI not to import the code, which is what you typically would do. You take all that lovely COBOL and you try and write it as Java, and you get a mess because it would not be the same, and it would be untestable, and no one knew what it was meant to do. They actually used AI to write requirements, to reverse requirements from the COBOL, and then they used the requirements to forward generate new code. And so they used the requirements, human readable natural language requirements, as the translation layer, which gave them the benefit that before they did any generation of the new system, they actually had the ability to go in and look at it, inspect it, rewrite it, go through the business rules, and actually decide, do we even want this? And apparently, allegedly, that worked better than traditional transportation of code.
Absolutely. So I think that makes total sense. I guess. I mean, I used to run a migration company, so or owned a migration company, and a lot of it was actually getting them to build up initially. What I said, we need to be able to test your system like for like.
Right.
First of all, don't add anything in when we migrate it. Don't say, oh, we've got this, we could change it, which is always a
might as well fallacy.
Might as well give it a go. So the first one was to actually set up a whole set of kind of regression type tests of their own original system. Now that then caused chaos because they were just like, well, do moan. Well, that wasn't in the budget and all that kind of stuff. But on the other hand, I said, well, like everything, if you do this up front, first of all, you'll understand it better. You'll probably find, and sure enough, they found a whole bunch of bugs in the original system.
Doesn't work the way they think.
Yeah, well, so that's a given. But then we did actually find a whole bunch of bugs because quite often with the migration, we would find bugs. And then they would be like, well, that's impossible. And then we'd say, well, can you go back? And we'd fight tooth and nail for them to go back and try it in their original system. And sure enough, it was a bug. It didn't manifest itself in the same way. And then what they found was there was someone from LC13 in the claims department would every month would go back and readjust the figures, and they'd be doing it for the last 25 years. And no one knew about it.
Right.
So there was all this kind of stuff in migration land, which was quite an interesting kind of way to approach it. Okay, yeah, I'm kind of liking that. So, but in terms of your specific software, is there anything sort of bill of materially? Do you think? I mean, would you they run your software for 6 months before a migration, and throw the kitchen sink at it?
And if they used our platform to design the requirements and plan everything and test everything and use our software in its entirety, they will be able to look at potentially all the code that's in the system. What requirements it tie back to, what defects, what do we fix, why do we make these changes, what code reviews did we do, how is it inspected? It would give you a good sense of that code. Now, inevitably, when they use our software, they probably come from somewhere else first. So there's probably a slice in time where from this day onwards, we can give you credence. Beyond that, we hope you migrated data into our system well from whatever sources you were using, and that's always going to be the challenge: is how good was their initial implementation. So from a new build standpoint, I believe that will be the case. If they've come from some other application, there's cleanliness issues, and they're probably dealing with legacy code, and so we can help them, but we're not going to solve it completely. And like anything, the danger is it's as good as the users. If the users, don't use our tool they do minimal code reviews, they don't. The tool lets you take a requirement, drill it down to tests, automate it, manual tests, exploratory or tracked, full auditability, put the code repositories in, link the code repositories, do the analysis, do your code reviews, integrate other tools into the. If they do all that and they have a beautiful, infrastructure and tool chain, then you've got some good data coming out. Probably they're not doing all of that, and then the danger is they'll minimize their investment. So I would say their investment in our platform will be fully realized if they're willing to go that extra mile and fully adopt it across a team or a product. If they're just going to use it do the testing, the rest we won't worry about. That's always the challenge. They'll use the tool for the 60% of what it can do that aligns with their current process, and then the other 40% they will go to them and say, listen, one of our partners could come in here and help you optimize the other features that you're not even using that you paid for, but would help you get quality up to this higher standard. Oh, that's too much money. We can't bother with that. So I think that's our challenge, and so we're trying to do that with our partners.
You use partners to do that, and they're.
Yeah, it's a new initiative we're actually launching right now called our Health Check, and we're what we're doing is we're introducing our partners to go to our customers. They fill in a survey, do an interview, and what the goal is for our partner to identify. You bought the software that can help you get quality to this level, and reality is you're using it as a test management tool solely, which is fine, better than Excel, but you're only getting 30% of the value. If you were to turn on the risk management module, which we have built in that you paid for, and link that and start to do risk analysis and do risk-based testing. If you were to use the exploratory testing add-on, instead of them capturing all their exploratory tests in QuickTime and sticking it in a Google Drive, if they use the capture tool, you can now capture those sessions and correlate those sessions, and you might see causality and patterns that you could learn from. And so again, by using these different, many of them free add-ons or features, they would improve the value. And so the idea is the consulting partner comes in as this somewhat independent of trusted authority that can come in and say, we've seen this with 10 other customers, do these 5 things and you can improve your quality, reduce time to market, reduce number of defects that you bring back into from production, whatever escape, quality escape as they call it at Boeing, avoid these negative outcomes. But I think if they're not willing to invest in retrospectives and looking back or having a partner do that, just using the tool by itself will never solve anything. Unfortunately.
Sound familiar, Rich?
Oh, absolutely. I think there's 2 interesting parts, right, in terms of, although lots of people will talk about quality, right, and quality is everyone's responsibility. They're kind of buzzwords that don't mean anything, right? And so until you start drilling down on exactly what Adam was saying there and having the conversation about what do these metrics mean, for example, right, then quality, even in an individual team, is many things to many different people, right? And so to have that conversation, to come to a consensus, and therefore go forward based on that, I think is really important. You also mentioned around the kind of the increased velocity, right? And I think again that's not really considered in terms of you can't have velocity and quality at the same time, right? I think they come hand in hand, right? In terms of there's a lot of waste in the development life cycle, and I think teams are stuck in a bit of a rut. That complexity, there's a combinatorial explosion both of complexity and also costs when you can't manage that complexity, right? And again, as you start to understand what matters, you understand what doesn't matter. You start to, you started mentioning around kind of observability, right? We will start to talk about isolation and things like that, right? What don't you need to do because there is no change past there, right? And again, there is an exponential explosion in terms of infrastructure you don't need, resources you don't need, which you're probably calling on today because that's what we did last time. And so, not just in terms of quality, there is a massive cost and speed benefit of actually, or you'll say, going slower to go a bit faster in the longer run. Get a grip of what you're doing, understand what you're doing, and then probably stop doing a lot of what you're doing now because it's probably the wrong thing.
You're absolutely right. I mean, people always say we haven't got time to do it right, but you seem to have plenty of time to do it wrong.
Yeah, absolutely.
And I'll give you an example from our own code stack.
I think we should reiterate first on that. We need to rename the entire podcast that now. I think that's it. That's the best description. We haven't got time to do it right, but you're sure I've got plenty of time to do it wrong. Brilliant.
It's true. I mean, and internally at our own company, so we deploy our Spira teams, our platform, and we can deploy it to cloud or on-premise. We have a cloud version and an on-premise version. It's the same core code, but when you get to the installer section, that's when it branches into two deployment packages. Think of it that way. So up until we get to deploy pre-deployment, all the unit tests or the automated tests, everything can be done on a singular basis. What we had in our pipeline was we had some really good testing for the on-premise deployment, and so we knew that when we gave someone the final installer package, not only had to be tested that it worked in our dev environment, but what they got installed it on the environment would be 100% the same and work, and the tests were valid. But for the cloud, we never quite did that because it's in our environment. We could always do it manually. And so we always knew that the on-premise was an approximation, but the number of times we go live and things will be wrong only in cloud, we have to go fix them. And so finally we said, let's just take a whole sprint. All it's going to do is we're going to extract the two different installation packages, and we're going to devise a set of unit tests and environment tests so that when we build the two deployment packages, we can say that they've both been independently tested to the same level, and a bug will never manifest in one, not the other, and really guarantee that so that every single action that those two deployment processes take has been independently tested. Now, a bug still could exist upstream, which would affect both of them for sure, but nothing would now manifest in one, that not the other. And by spending maybe, I think it was a month just doing that and nothing else, which is an expensive investment of time for a company, we now never have to test that again. So it was a month of
investment. You say it was an expensive investment, but was it? Because you've essentially halved the work, right? For the long term.
Right. That's why I say it was actually a very cheap investment, but it would be perceived as that's a month. It's 12th of our entire development budget was spent. That's a lot of money. But then we never have to test this entire set of work for the next 10 years. That's a save. Again, it wasn't the entire team. So it was more like maybe a 50th. But again, as you said, it's a very cheap. It's an investment. But people don't say investment; they say it's a cost.
No. And I think when you get into large organisations, you mentioned there's a cost, but that again that's massively exploded as you get into one department, then integrates with another 3 departments. What is the burn rate of each of those departments, and therefore what is the waste that you multiply this over. And a system might exist for 10, 15 years with an organisation if they're fairly good. They won't ever decommission anything, but you think of the amount of wasted effort in just not getting it right or not refactoring the architecture.
Right. You're living with it for the rest of that system's lifespan, which is longer than everyone ever thinks. By the way, why do we call it cost? Maybe we should call it investment. I mean, that could be the fault of language. Like as software professionals, when we go to get money for something, we'll say, oh, the cost of this sprint is going to be X, or the cost of this testing tool. We should say, the investment we'd like to make in improving quality and reducing cost is this. And they might say, the budget might be, they open the budget more easily. They get the wallet out, like, oh, that's much better.
Yeah.
I don't know. What do you think, Huw?
What were we talking about? Refactoring. I mean, we were talking about. Well, I think it probably comes up pretty much every podcast. Really, is just you've got to get your users used to refactoring being something that happens either as part of a sprint or when you're maybe, as you say, you took one sprint or something like that, and you said basically let's put some refactoring in here. We're just building up too much technical debt, and you just keep saying that to them all the time till eventually they go okay, and then it just has to be part of how you build software because they're very keen to have this new sexy feature, but you've always obviously got to say we're happy to do that. It's actually not too much code to show you, but for us to harden that. and we'll release it, and it will go out, and it was going to be able to produce that report for this thing. But thereafter, it has to actually come back into the fold. We're actually going to make it a meta object. It's going to be auditable. It's going to be all of those things are going to happen to it. We're happy to let you have it, but then it's going to have to be refactored and brought in. And I think that has to be just become into the vernacular of how we communicate, and how people think about. We actually took way longer than we probably took close to 6 months refactoring our back end. It was probably one of our best developers for that entire 6 months, and
wow.
he was our most productive developer. And it was we were about 2 years in, and I was like, well, we've already built up 1 year's technical debt, and then we've got to write all these custom reports to find things. Why don't we just come up with a generic concept, which is kind of a meta layer where we track everything in this very flexible way, and then means we can use kind of graph database concepts to go find stuff and do impact analysis and all that kind of stuff. And there was a bit of pushback initially, but actually now, looking at the product, you just have this tiny little thing which looks like a tree, and you click on it, and whoosh, you can go and find, where's that used? Where's that? I mean, there's still a little bit more to do on it, but I mean, it was pretty fundamental, and it's now holding us in good stead. We can add in other objects, but they fit very much just in as a component, and we created this thing called data activity components. So anyone who came up with a brilliant idea for something that they wanted to do with test data or real data, we just plumb it into this little container, and that has most of the stuff that we need, apart from the clever stuff, which should be inside this container. And as soon as we did that, suddenly we would be able to move way faster, and actually the product, probably in the last sort of say 12 months, we probably have to put 3 to 4 times more functionality in than we would have been doing previously.
So your velocity's increased based on that investment. Big
time. So I think, but I think you have to do it as you're going along as well. So I think this kind of refactoring has to be kind of built in. And it might not even come from your team. To coming back to Rich's point, you tend to work in isolation, and there's these horrible feature factories which are turning stuff out. But then other people who are consuming you or using your API are saying, look, this is a nightmare. We cannot test your API. We can't get at the data. We don't know what the hell's going on in the back end. It's sending messages right, left, and center somewhere else. We don't know what that is. So you need to provide us with something which allows us to send a message which is observable, so we can then track that through all the systems, so we can test it. So we know where it came from. So we know that it went through the loop and came back to us. And they'll go, moan.
I think to go full circle on the conversation, right? A lot of, especially regulated organisations, they've got resiliency obligations back to their regulator, right? And platinum service lines and things like that, right? In terms of, you need to demonstrate that you understand how the core really important services within your organisation work, right? Back to Adam's point around conduct risk, in terms of, if a customer wants their money within a certain period of time, right? You need to be able to do that, and there's regulations around that, right? And I think there's a really interesting challenge in that, where you've got a lot of organisations that are a big ball of mud, actually decoupling those resiliency lines is nigh on impossible, right? And then underpinning that, you've also got this conversation we've been having, right? That organisations don't really understand how those systems plug together. So I think there's some really kind of awkward internal conversations that are going on in terms of, do we actually really understand how these very important service lines work in our organisation, and how outwardly do we satisfy our internal auditors in terms of evidencing that we understand our systems, but we also make change in a risk conscious way.
Right?
There's a lot of challenges that organizations are aware of, and possibly head in the sand, or slowly starting to face into. But it's a real challenge. Where do you start, I think, without kind of stopping the endless feature factory demand of the business?
It's a hard nut to crack.
I think that's a good cliffhanger to leave this podcast, I think.
We'll end.
Sure.
Yeah. Adam, any final thoughts, Adam? It's been great to chat with you.
Yeah, my final thoughts are really only that if you look at the world we live in today, software 20 years ago, 10 years ago, if it failed, maybe there were more options for workarounds. You're looking at the entire car dealership network in the US went offline last week because of a cyber attack. In the UK, I remember there was that issue where all the e-gates went down at the Heathrow Airport. I mean, in the old days of software, if particularly some of this stuff is just business software, it's not complicated software. It's not real-time software. Many of it's just business software. But in the old days, if business software went down, you get your pen and paper out. And at the end of the day, you batch record, and the weekend when it comes back up, you'll fix everything and reconcile everything. Or there were backup methods. Because we were using software, supply chains are tight, so customer service reps have been scaled back. We're relying on software to be the glue that holds our society together like never before. That I truly believe things that we often thought of as non-essential software really is essential software, and that therefore the risks of things breaking is so much higher at a societal level than ever before, that we have a moral obligation, not just a technical obligation, to be better at quality. That's all I would say.
Yeah, absolutely. I kind of like your point about the EU, because they have actually, the horrible Brexit argument was, we lost control, etc. But really, the EU was an incredibly technocratic organization, and when that's where you had lots of tiny little boring experts sitting there looking at this boring nitty gritty and coming up with, really solid ways that when chemicals, this is the way you test a chemical. Fact. Right. It's not up for debate. We've looked at the best in the world. We look at all the academics. This is the way you do it. And you impose slowly more of those things. And it seems like, if it can start applying those to IT, it's a bit like the catalytic converter in California. Suddenly everyone has catalytic converter.
Yep.
So as soon as you move into any one of those markets, everyone wants to move into the EU market, then that kind of discipline hopefully can come down. I mean, there was GDPR, which was just, people have basically just tried to scuttle around it in terms of using production data in development, which is just bizarre in my point that anyone's even attempting to use that anymore. But it's still prevalent out there. But when it comes down to money going out the door, which is in effect what you've been outlining with some of these risk failures, and reputational damage, never mind the fines you're going to get, plus the embarrassment factor, et cetera, it has to be done.
100%.
Cool. Fantastic. Good to see your lovely smiling face again, Adam. Hopefully one day we'll sit down in the old-fashioned way and have a beer.
Maybe Automation Star or Eurostar next year or
something
Star
like
West.
Or one of them. Okay. All right. Cheers, lads.
Cheers, Adam.
Take
All
care.
the best. Thanks. Bye-bye.
Thanks for listening to this episode of the Why Didn't You Test That podcast. To continue the conversation, head over to curiositysoftware.ie. Subscribe for more episodes.